Hello everyone, my name is Ryan. I'm a tutor at the Thermochemistry Center. We're located on the second floor of JPO. And today we're going to be looking at a general chemistry 1 problem, the topic being thermochemistry. So after you read the problem statement and you look here to the right side, you know that the sample of water is going to be going from negative 30 degrees Celsius all the way to 140. So at negative 30, it's not going to be water, it's going to be ice, so it's going to be in solid form. And then once the phase change occurs, which is at 0 degrees Celsius, because that we know that's the point water starts to fuse into going from a solid to a liquid, and and at 100 degrees Celsius, water starts to boil, so it's going from liquid to a gas. Okay, so Q1 will be from negative 30 to 0. That's the amount of energy it takes to go to 0 degrees Celsius from negative 30. And then we need to calculate how much energy it takes to change states, so solid to liquid. And then Q3, that's going from 0 degrees Celsius to 100. Q4, that's again, we need to find the amount of energy it takes to change from a liquid form into a gaseous form. And then Q5, that's going from from 100 degrees Celsius to 140 degrees Celsius, which is our final temperature it wants in this problem. So it wants us to calculate the Q for the entire process. So that's just going to be the sum of all these Q's that we're going to solve individually. Okay, so Q1, let's start with Q1. That's going to be MC delta T. Okay, and M is going to be mass of H2O. They don't give us a mass, but they do give us a mole of H2O. So let's first find the mass of H2O. So 1 mole of H2O equals 1 mole of H2O, 19.02 grams. That's this is just using the molar mass of H2O or water. So then moles cancel, you're just left with 18.02 grams. Okay, so now we have grams. We do have specific heat of ice, which is given to us in the problem statement, and delta T, we have that as well. So Q1 is going to equal 18.02 grams. That's what we calculated. And C is just going to be 2.03 joules per degree Celsius times grams. And our initial temperature is our final temperature is going to be 0. Then our initial is negative 30, which is why I'm putting it in parentheses, because it's always final minus initial. So after you calculate this out, you should get 1097.4185 joules. Okay, and Q2, so now we're going to have to switch equations since we're undergoing a phase change. So for this one, you're going to use moles times, and it's given to us top delta H of fusion, because we're going from a solid form to liquid form. So delta H fusion. So Q2 is going to equal moles is given to us. It's given to us on top in the problem statement, and this one as well. So 6.02 kilojoules per mole. Okay, moles cancel, so the answer is going to be 6.02 kilojoules. We do want to stay consistent with our units, so let's convert this kilojoules into joules. So we know that 1 kilojoule equal to 1,000 joules. So that's just going to equal 1,000 joules. So far we have this one, and then we have this one. So now let's solve for Q3. We can switch back to MC delta T, because here no phase change is occurring. We're already in liquid form. We're just going to be going to 100 degrees Celsius, because we know at that temperature water is going to change states. So Q3 equals 18.02 grams. That's what we calculated before. C is going to be given to us in our problem statement, which is right here. So 4.18 joules per Then, so our final temperature is 100 and our initial is 0. Okay, so then after we calculate this one out, we should get 7,532.6 joules. Okay, so this one is our next Q that we calculated. And then Q4, this is another phase change is occurring. So delta H, and then this one is also given to us, which is right here. So Q4 equals, so 1 mole of H2O. And then, which was, 1 second, which is 40.7 kilojoules per mole. So moles cancel, so we're just left with kilojoules. So Q4 will equal 40.7 kilojoules, or after we convert it, it would be 40,700 joules. Okay, so this one is the one we want. And so Q5, we can switch it to the other equation, MC delta T. No phase changes occurring here. So 18.02 grams. And then this one right here would be specific heat of steam, which is 2.02 joules per. So, and then we're going from our final temperature is 140, and our initial is 100. So Q5 will equal 456.16 joules. Okay, so that's our last Q that we want. So now that we've solved all these Q's right here, so now we want the sum. So now we want the total amount of energy it took to go from -30 to 140. So the sum of these is going to be 56,805.794 joules. So that's the entire amount of energy it took. And if you do want sig figs, it seems like the problem is consistent with 3 sig figs, so we can convert this to be 5.68 times 10 to the 4 joules. Okay, so thanks for watching, guys. If you have any further questions, just please come visit the Q Lab. Thank you.